Okay. Uh, Hello, everyone, and welcome to the latest episode of Scrubbing the Skies, the webinar series of the Institute for Responsible Carbon Removal at American University. The Institute is a research group that focuses primarily on a vision for responsible carbon removal, with a focus primarily on issues of governance and ethics and public engagement in the development of the carbon removal industry. And that mission is perfectly aligned with the topic that we'll be discussing today. Uh, Enhanced rock weathering, I think it's fair to say, within the last 6 months to a year, has had a real star turn in the constellation of carbon removal approaches, with several announcements of large purchases, including in the voluntary carbon market. And one of the emerging questions has been, can enhanced rock weathering be one of our approaches that, one, have compelling co-benefits, which obviously helps support it in terms of public acceptance, as well as potentially bolstering the business model for this proposition? And second of all, is it one of the approaches that can be developed in the global south in a way that helps not only address climate change issues, which obviously disproportionately impact the global south, but also provide business opportunities, as well as some of the kind of co-benefits that we're talking about in that region? And can it be done responsibly? And can it be done in a way that creates a viable business model for carbon removal companies? And we have an excellent speaker today to talk about that, given the experience of his company, Mati Carbon. And I'd like to introduce Shantanu Agarwal, who is the founder and CEO of Mati Carbon. And what he will do today in the initial intervention is provide an overview of the company, the approach, some of the areas that they're working in, and some of their experience to date. Afterwards, as usual, I'll seed the initial conversation with a few questions, and then we will move to audience questions. And so, in that context, I would encourage everyone to start propagating questions in the Q&A box as they arise during the initial presentation, and then we will proceed to those questions. And so, welcome everyone. Welcome to Shantanu, and we welcome your initial intervention at this point.
Thank you, Will. I really appreciate the invitation to speak here at this August forum and explain to our audiences the value proposition of Mati Carbon and our team, and how we are trying to come together to solve one of the most important global problems around smallholder farmers. If you would allow me, I can just run you through a few slides and before we go into Q&A. And through the slides as well, if there are questions, we can address them, but let me just take this on from here. So the entire purpose for Mati Carbon to exist is to serve the smallholder farmer of the global south. And to that extent, we have built a company which is financially and legally structured to serve the farmer as the primary stakeholder. And we've also hence primarily fundraised through grants and now debt as our scale-up mechanism. And we continue to do that because we would like to put the farmer first, and in a lot of cases globally, as a lot of these carbon removal technologies have come of age and scaled up, they have become more of a value extraction mechanism for the global north rather than a value reward or value providing mechanism for the global south. So to that objective, to ensure that the farmers are the biggest winners, in the case of Mati Carbon, we have created a legal structure to really put them first and far ahead of everyone else as we scale Mati Carbon. Who are these farmers? Let's talk about that. These are some 500 million smallholder farmers across the global south, probably more like 700 million. And these are, I'm counting the farm holds rather than the farmers. So this is based on our analysis and some of the reports which have come out with FAO and World Bank and folks like that who do these kind of countings. And what that means is 500 million farm holds is equivalent to most likely more than 2 billion in population. So 2.5 billion people in the world depend on these smallholder farmholds. They form the bulwark of the food security of the world because the food they produce is in some of the poorest areas of the world and actually gets distributed amongst the biggest population centers of the world. And as compared to sort of the global north farmers who are producing probably a larger section of the total food produce, but it's not actually being utilized in providing food security to a large number of people in contrast to the smallholder farmers. So these farmers are seriously important to the global food security and economic security and the global health. And they're all facing a significant climate challenge with the climate extremities and the dependability of their rainfalls and the climate temperatures, which they have got used to, which is what defines their ways of farming and their ways of livelihood, are changing on them and quite substantially in some of the locations which we are working on already. The studies from folks like McKinsey and BCG and others have estimated that more than 80% of these farmers will not be able to continue farming the way they are doing it today, or their livelihood, their mechanism livelihood will be severely affected by 2050 because of the climate hazards created by climate change. And the World Bank talks about that the ANR financing gap, which is adaptation and resilience financing gap, to allow for these farmers to be able to bridge the gap of where their livelihood can be protected. On an annual basis, you need $300 billion in funding to really allow these farmers to be able to become resilient. A large component of these populations live in sub-Saharan Africa, which already face severe food insecurity. We are working with some of these farmers in Zambia, and we can see that the climate change is already here. For a lot of us living in the global north and in countries where we can still say that climate change is going to come and it's happening, it's not so severe at this point. You can go to southern Zambia or central Zambia, where the droughts have been very severe for the last 2, 3 years. The rivers are flowing at 20%, 10% of their typical volumes. The hydroelectric plants are not running or running at significantly under capacity. There is 2 hours of electricity a day being supplied to these populations because of the subscale hydroelectricity happening. And at the same time, the droughts have killed their food productivity. So these are the type of farmers who are already getting affected very significantly by climate change. And there's more of this happening across the global south, especially in the tropics. So that's the farmer we are trying to serve. These are the farmers, these are people, a large segment of the global population, probably 1 in 4 people, who are at the severe end of this climate vulnerability, who need support and solutions. At Marty Carbon, we believe that we can actually solve for this through a process which is called enhanced rock weathering. Now, now rock weathering is something which a lot of people don't understand or think that it's what are I talking about? Is it something which is natural or what is it? It's quite new actually, but it's also something which is even older than plants. So it is one of the two ways by which the planet removes carbon. The planet, Mother Earth, removes carbon by photosynthesis, which is all the trees, green plants, which you see all over the world. And we all want more plants to take carbon out of the air and put it in our vegetation. And that's great. That's basically the short-term carbon cycle where plants grow quite quickly, capture the CO2 from air, and become organic matter. But also at the same time, these plants are subject to getting cut down or burned down or getting rotten very quickly and releasing that CO2 back to the air. So that's a short carbon cycle which naturally occurs. And we need to sort of continue to sort of scale that. But the other carbon cycle which the planet has naturally is the rock weathering or the inorganic carbon cycle, where uh, alkaline rocks, which are almost a large component of the volcanic rocks which exist on the planet, similar to basalts, olivines, all the different plagioclases, are essentially very reactive towards carbon dioxide and water. So naturally, carbon dioxide from the air and water from rainfall mix together and form a very weak acid, carbonic acid, which reacts with these rocks, which are naturally occurring on the surface of the planet. And as this reaction happens, these rocks weather. And that's why we call rock weathering. And naturally, this is already happening at hundreds of million tons per annum scale, almost a gigaton per annum scale, one of the biggest carbon removal sinks of the planet, which just happens annually already. And in this reaction, over a period of time, actually over a millennia, rocks convert to soils. That's how soils are made. That's how nature converts massive mountains into beautiful soil which we can grow plants in. So what we're doing when we're enhancing rock weathering, we're essentially accelerating this natural process of carbon removal. And at the same time, we are um, getting the co-benefits of this process, which are quite interesting as well. So how do we enhance this process? How do we hasten this process, which normally naturally takes a million years? We essentially break these rocks into very fine powders. These fine powders essentially have probably a million times more surface area than their natural base monolith rock formation form. And as we increase the surface area by a million times, we essentially increase the reaction rate because we have essentially created a massive increment in the reaction surface. So the reaction, which would otherwise happen over a millennia, starts happening over a few years. And in the process, what happens is the volcanic rocks, which have calcium silicates, magnesium silicates, and iron, copper, zinc, all these various nutrients, which are naturally occurring in these rocks, they get they react with this carbonic acid, and in that they essentially hold on, sorry, I have opened this window. Sorry about that. Yeah. So in that process, they essentially release these various nutrients into the soil and also form bicarbonates or sequester the CO2 in the form of bicarbonates. So now these nutrients, which are calcium ions, iron ions, zinc ions, are essentially balanced with bicarbonate ions, which are also released from the same rock. And also plant available silica is released at the same time. So all these are essentially now sitting in the soil because we have just added it in the agricultural soil. And these nutrients are coming to the field and rejuvenating this degraded soil typically, which exists because we have farmed multiple years, even hundreds of years, and not really added these nutrients into the soil. So suddenly there's a rush of all these nutrients in the fields, and the field's biome improve, and the whole ecosystem around these soils improve. At the same time, we have essentially captured the CO2 and sequestered it in the bicarbonate form, which then runs off into the rivers and the groundwaters and eventually into the ocean, where it is sequestered for tens of thousands of years, almost permanently as far as human scales are concerned. So this natural process of weathering, when we accelerate that, not only is providing alkalinity to the rivers and also the oceans where acidification has been bleaching our coral reefs. So it's also solved for that, alongside improving the biomes and the nutrients in our soils so that they can actually be more productive. So it's a beautiful win-win for nature, win for mankind, and win for the farmers when we do this rock weathering at massive scale. And that is what we are trying to scale up and grow this process into a global phenomenon. Uh, In terms of where it can be done, we have done a large analysis of globally where it can actually work. And based on our analysis and the global deposits of these rocks, we believe there is 200 million smallholder farmers across the planet who can actually benefit from this process. There's 870 million acres of farmland in the global south, which can benefit from enhanced rock weathering, which is within 200 kilometers of source rock like basalts, which can actually spread into the farmers' fields and allow for them to have increased productivity, better climate resilience. At the same time, be funded by carbon removal credits so the farmer doesn't have to pay anything. So this can be a massive, massive solution when you're talking about 200 million farmers, which can be touched by this. What can this do? In our experience with more than 10,000 farmers now who are our partner farmers, typical crop yields go up 20 to 30%. We see reduction in the need of pesticides for farmers. A large majority of them tell that there's no more, there are much lower amount of crop diseases. And typically the additional cost to farmers is $0. So we are not charging anything to the farmers. The whole process, in fact, even the spreading in the farmers' fields are entirely free. The farmer literally has to do nothing to get this benefit. And we fund this through the removal of carbon in their fields, which we measure through our technology. And there's about 1 to 3 tons of carbon removal, which can happen per acre of farmer fields. Now, all of this, the circle goes round by actually doing a sale of this carbon credit, which are generated. That's how we are essentially funding the whole process. And to that extent, the carbon removal which we're doing is concerned, it's considered to be a highly durable carbon removal. And it is durable because it has more than 10,000 years of permanence, as proven by the various models and academic journals which have been published to that extent. And so the pricing which we are able to get from the market is at a premium from the traditional avoidance credits or the nature-based credits. So the nature-based removals are typically $25, $30 per ton, even $40 per ton is what we have heard. And avoidance credits are sub $5 a ton, as you can see from the chart. But the technology-based, highly durable removals are north of $200, even touching $400 per ton. In some cases, like direct air capture and others, BECCS, these are all highly durable and high quality carbon removals. And enhanced rock weathering essentially sits in this bracket of technology-based durable carbon removal. And there's an increasing demand from customers for these sort of carbon credits, which we are seeing in the marketplace and trying to serve. In terms of some of the forecasts on how much this volume can be in the low scenario, this is the BCG carbon removal report. BCG estimates that the carbon removal markets could be up to $10 billion by 2030 and 20 by 2040 in the low scenario, and could be 40 billion by 2030 and 135 billion in the high scenario. So it's a massive market which is getting unlocked because of the net zero targets of companies and countries, and something which us as mankind very much need, because otherwise climate change is gonna make our livelihood and the current way of life quite different. So this is a market which is growing and can support a significant change and scale up for smallholder farmers at the same time. This is an example of what we are presenting in terms of farmer income increase, which we can deliver to farmers. Of the 100 million farmers which we hope to impact, we estimate that we can deliver $300 per annum per farmer an income increase. And in fact, we have already delivered more than $1 million in income increase in 2024. With more than 10,000 farmers, and actually more than 2,000 farmers who already benefit from these income increase. This number is old. We are seeing that we have a very, very scalable pathway to deliver income increases for farmers across the global south. For average soil farmer who makes about $1,600, $1,200 to $1,600, the 20% income increase by enhanced weathering itself can be about $320. And on top of that, we see that we can also give them a share of the profits or actually all of our profits, because we are essentially a nonprofit controlled entity. We can give them all of our profits, 100% of the profits to them to make their income increase up to $400 per annum on a steady state. Apart from that, we are looking at various insurance solutions as well for farmers to help them with calamity insurance and allow for them to be more resilient. This is even more pronounced for degraded soil farmers, where annual income is $1 a day. These are farmers which I'm working with in Zambia, for example. Really, really poor, destitute farmers, $1 a day type of farmers. And for these farmers, typically $500 per annum income. Still, five people to support, very low quality of life, but degraded soils. So when we put our soil amendment in their fields, we see 50, 70% incremental benefit in productivity. And that is a huge change for their overall income, because you just get 50% more income on an annual basis. And on top of that, we also, again, share the same. All of our profits go to them. And that could become $350 per farmer per annum increment. That's like a 70% incremental income on the farmer on a consistent basis every year. So this can be huge on a consistent basis, both for the climate and for the small farmers. We've already scaled quite significantly across the planet. We are running across to try to activate this in various new geographies right now. Our headquarters is in US, where all of our R&D partnerships are also. We work with the Yale University, Yale Center for Natural Carbon Capture. We also work with University of Sheffield, Leverhulme Center for Natural Carbon Capture, or Carbon Capture, actually, LC3M. So both of these centers are key to our scientific innovation. Apart from that, we have a bunch of institutions in India as well who are supporting us, like IIT Kanpur, Indian Institute of Science, and various agriculture institutions who we have collaborated with. Apart from that, we have obviously scaled up in India quite significantly, more than 120,000 tons as of counting us today, delivered into the ground. And we are aiming to deliver 300,000 tons in 2025. And we are also scaling up in Africa, in Zambia and Tanzania. And we hope to add a few more countries this year. Based on our analysis and partnerships across the globe, we're looking for partners who want to do this model in their area, in their regions, and we would like to welcome those partnerships for scaling up this with smallholder farmers across the planet, especially in the global south. To unlock enhanced rock weathering for the full scale, you obviously need high quality MRV and localized MRV, which we are building. We're partnered with the standards organizations to do that. And the second unlock is basically the CDR customers. To that extent, we've got a bunch of customers already and more who we are trying to contract with. And these customers, who are the prime economic engine to purchase these credits and become net zero themselves, are essentially going to be further important as we scale up, and we need more and more of these contracts as we scale up. Not only, we also believe that voluntary carbon markets are not going to be sufficient on their own. So compliance markets have to come into play as we scale this further. And last but not the least, we need blended finance to reduce the cost of credit to do this, because it needs to be scaled up, and large multilateral banks will be a very important role to scale this. I'll end here and sort of open this up for questions. I believe that this is an opportunity where just 50% adoption of enhanced rock weathering across the viable regions can lead to more than $30 billion in additional farmer income per annum, and allow for climate resilience for more than 100 million smallholder farmers, which is probably almost 500 million population of the planet, and also deliver gigaton scale carbon removal. So we are very excited to be part of this whole movement, and we welcome partners and suggestions. Thank you for giving me the opportunity.
Thank you, Shantanu, for the overview. I'm just gonna advance a couple of questions, and then we'll go to audience questions for which we have an abundance, though I think I'll consolidate some of them because they have similar themes. But uh, one thing I'm always interested in the context of ERW, and I think there's a couple of questions in the chat also about this, is the MRV process, right? We know it's challenging, right? We know that certain methodologies that have been used have been controversial, especially those that focus on modeling, given the variability in the climates that we face and kind of some of the signal to noise ratio questions, right, in those measurements. It's my understanding from reading over the peer-reviewed studies that you cited that you use site-specific soil composition analysis, and I'm curious as to what that looks like, why you think that's a sound process, and if you faced any challenges to date in utilizing that process in the areas that you're working in.
Yeah, so very pertinent question. I think the biggest challenge which we get is that this is an open system MRV system where
Mhm.
we're trying to measure nature and how do we accurately measure the carbon removal which is happening. So I'm fortunate to have been collaborating with giants in the space and building on their research for tens of years. So David Beerling out of LC3M in Sheffield and Noah Planowski out of YCNCC have been key to our development of the MRV process. And there are lots of other academics as well who have helped us along the way. But what we see is that uh, these MRVs can't be generic. You can't just pick up something from, for example, we started with a MRV which was developed in Illinois in the energy farm, and we were trying to bring it to rice paddies in India, and we took the methodology and tried to apply it, and we got garbage. So, so, so by by design, I think nature is heterogeneous and very different, and you have to really respect the heterogeneity of nature to try to measure signal in a natural system, an open system. And yes, the theory and the science is the same. I mean, the reaction which is happening, the rock weathering reaction, and the underlying science is exactly the same everywhere, be it Illinois, be it middle of Sahara, be it Zambia, be it India. However, to be able to capture that signal, you have to really understand what's going on in the soil, the geochemistry of the soil, the chemistry of the water, the ways the farmer is interacting with these natural components, and the ways the climate is interacting with these natural components. And only based on a bunch of empirical data can you actually qualify your system and understand what's happening, because you cannot I mean, we have tried and we don't know at the moment how to do this, but theoretically, just working off a formulaic basis of applying MRV in a new region will not give you good results, because it's just not how nature works. And we are trying to figure out signal from noise in a very noisy system. And to determine that signal, you have to experiment and you have to collect data. And a large amount of data over multiple years is the only way that you can have a reliable MRV. And that is the reason we are not hasty in essentially getting certified in a new location or a new region and getting selling credits when we start up in a new region. We are essentially uh, collecting data. We collect a bunch of data. We take a lot of time. We spend at least 2, 3, 4 seasons of uh, farmer uh, experience and our experience collecting those samples and measuring those samples before we get the confidence that, okay, now we have a theory and a practical empirical proof that this data is behaving in the way the theory should. The theory is suggesting that it should behave, and that means that we have to adapt through those few years in how we are taking the samples, how we are essentially um, maintaining the periodicity of the samples, and how we are measuring. All those things have to be adapted, and and then we can essentially come up with a method which is specific to that area and gives you reliable data. So it's a technical challenge which we have to solve for, and that's what we are doing. And we've done in India in the rice paddy agroecology zone, and we are expanding it and now doing it in Zambia and in Tanzania and in other regions in India as well. So we have to be patient with nature and let nature teach you what she's wanting to do.
Okay. All right. Thank you for that. So you've talked about engaging with a large number of smallholder farmers at this point, and I'm curious what that public engagement process looks like and what are the questions that you get in that context, right? Because I mean, one thing I know from the agricultural sector growing up as a Midwest boy is it's an extremely conservative sector. Even in rich places, the profit margins are often extremely thin, and so people have a lot of trepidation about trying anything new, right? That could be disastrous, right? Even if it's promised to be salutary, right? So what's that public engagement process look like, and what kind of questions do you get?
Yeah, so think about this, that I mean, you're dealing with a smallholder farmer, let's say in Tanzania, and you come to their village and you say, "Oh, I'm visiting from US and I've got this magic dust which I'm going to put in your field for
Yeah.
free. And don't worry, it's not going to harm you, it's going to actually help you, and I'm not going to charge you anything." And they'll say, "Oh, okay, what's in it for you?" No, no, we just want to help you. I'm like, okay, nobody wants to help me here. Everybody's trying to extract value of me. So then you try to explain them the whole carbon economics. You're saying, oh, actually, we make our money by removing something in the air which you can't see, putting it in the soil and the waters where you can't see it, and somebody far away is going to pay for it, who you can't see as well. They're like, run away from here, right? You must be kidding, right? So that's the story we have to sell. So it's really, really difficult to explain it to farmers who are typically uh, working off their experiences and their what they've seen in their lives in their own eyes, right?
Hmm.
And and so you have to build that trust by giving them experiences with their own eyes. There is no alternative to that. You can't just come and give them theory. You can't just come and tell them that, look, this has happened in the other place and that farmer actually helped. That helps a little bit if it's the farmer nearby, but if it's a farmer from another country, they're like, didn't happen in my backyard. I don't trust it. Right. So essentially the only way to sort of convince them is to give them trials, show them this can happen, show them this actually benefits them, show them and let them experience it. And hence the whole enhanced rock weathering scale up process, if you want to do it right rather than sort of force feeding it to a farmer population, takes time, because you essentially have to let them experience it over a year or 2 years to see that, okay, this is real, this actually benefits, this is not harming me, they're not charging me, they're real people, they come back every year, they're not running away.
Hmm.
All these things which they have a lot of questions and worries about, that why are these guys here, I mean, and the other question is that, oh, you're giving it to us this year, are you going to give it to us next year?
Right.
What's going to happen next year? They're
Yeah.
concerned about next year first rather than this year. So a lot of those concerns, and they're like, oh, you're going to make us dependent on this material. Once you put it in the field, then our soils are gonna depend on it. Then we'll have to pay you for this. You're essentially making us depend on you. So I mean, all sorts of questions exist, right? So, and rightly so. I mean, we are dealing with a farmer who's got 1 acre or 2 acres of land, and they're essentially dependent on their survival for this production of
Yeah.
this land. And they get one crop a year because that's the rain, right?
Yep.
So you're telling them that, oh, here we go. I'm a nice guy here. I'm going to give this to you for free, and I'm going to alter your one crop a year by this.
Right.
That's their livelihood. That's their food. That's their whole economic security. They cannot take that risk. If you're a 2 acre farmer, you cannot take that risk that, okay, this can actually damage something. I can't take that risk. I just can't.
Right.
So it is not only the nature is slow, but even the adoption is slow because you have to essentially help the farmer experience it, and there is no way around it.
Yeah. If it's not an unfair question, what's your conversion rate, right? Because one of the things I'm trying to figure out is assuming there's going to be a large percentage that are just not going to take the risk, right? What ratio of those that you're touching are adopting at this point?
So I think it's a very fair question, but I wouldn't say that there's a straight answer for it. I would say the first time you go to a place where you have no trust, the conversion rate is zero.
Right.
So you have to figure out a way to build that trust. You have
Hmm.
to either convince some of the more educated farmers or come up with a friend of a friend of friend or whatever, There has to
Right.
be, I mean, a Zambian farmer, a tribal Zambian farmer who doesn't speak English, doesn't know me from Jack, and would not let me in their farm, even if I do whatever I do, it doesn't matter. There's
Right.
zero conversion. So I think the journey is from how do you actually transfer the trust into the farmer's mind that, okay, this is actually going to help them, and then allow for them to experience it. What we have observed is that after the first season, where they have some examples nearby where they can go and see the actual difference, and God is very kind that the actual productivity difference and the farming difference shows up in the first season itself. So we don't have
Mhm.
to wait. So in the very first season of productivity of the crops which we're growing, we see a difference for the farmer straight away. And when that happens, the next season, when we come back and try to talk to the farmer, they are much more, much more open to talking to us. And so in the next season, the conversion can be as low as 10% to 50 to 60%. And
Hmm.
then as that sort of one big trial happens in a region or in a village, then once they have seen that their neighbor has got increased productivity for free and they were actually able to touch and feel it and see it grow, then I think the season beyond that is everybody wants it. You know, it's a once it's proven that it works and these guys are not lying and it's like they can trust it, then these are also farmers who are in some ways depending on each other, right? So if one of the farmers says this works for me and they believe that farmer, then the other farmer is very quick to say, oh, I want to adopt it as well because my friend who I trust completely experienced it and he says it's good.
Great. Thanks for that. Okay, let's move on to questions from the audience. First question from Edith Katz is, how does the ERW work in regions which are in drought or arid and the water needed to trigger the carbonate process doesn't exist?
Yeah, so water is one of the reactants. If you have no water, there is no weathering.
Right?
As simple as that.
Yeah.
So it's not going to do anything if you take this dry basalt powder and put it on a in a in a ocean of sand and
Hmm.
let it just sit there. It's not going to do anything. So we need water. So if you're in an arid region or a drought region, um, I think if they have a rainy season, I think it'll still work. If they have no rains and it's completely dry and it's kind of very arid, then you need irrigation. If you don't have irrigation, I mean, water is needed. It's one of the reactants. Without water, there
Right.
is no weathering. As simple as that.
Right. So so there is some rate limiting, right? In the global south, I would presume, given those conditions, right? That's fairly substantial, right?
Absolutely. So, yes, we cannot go everywhere, and we're not claiming that this is a solution for all 500 million farmers. This is
Right.
a solution for a large segment of those farmers, and but it has its limitation. It needs the rocks, it needs the water.
Okay. All right. Next question from Mark. This is a two-part question, so I'll disaggregate it. The first part of the question is uh, your source of feedstocks for the weathering.
Yeah, so the source of feedstock which we're using today is basalt.
Hmm.
And we use basalt because basalt is the most benign rock. There are rocks which have higher carbon removal potential and faster reaction potential. But the beautiful thing about basalt is that a lot of the soils which we are farming on today as mankind are made out of basalt weathered rock, and the soils are essentially extracted out, I mean, converted basalt. So
Hmm.
it is a very common feature across the planet, and it is also a very benign rock in terms of the heavy metal compositions of it. So using this at scale is not going to hurt anybody. That's the first thing which we care about, because we are dealing with the most uh, sort of uh, climate vulnerable and smallholder and poor farmer of the world. And the worst thing we could do in our mission is actually harm that farmer rather than benefit the farmer. So we have been extremely conservative in our approach to use the most benign rocks. And there is, fortunately, a massive quantity of this rock across the planet. In
Hmm.
fact, just in the Deccan Traps, which is in India, where we are already working,
Right.
like I might be wrong with the number, but 0.01% or something. I mean, like a very, very small percentage of that Deccan Trap basalt rock. If you just take 0.01% of that, and uh, might be 0.1% or it's 0.01%, one of the two. Uh, just that small fraction of the basalt rock of Deccan Traps can take out all the carbon in the air which has ever been emitted by the planet, and all of that can go into the ocean. So the the sheer amount of rock available on the planet to do carbon removal is humongous, and there is no shortage of these rocks on the planet. So we're not there's no restriction there.
Okay. The second part of the question is are the environmental implications, right? So obviously, when you start with this rock, you're going to have to grind it up finely, and there's all kinds of things that are talked about, right? The fact that this could be an extractive industry that was as large as the hard minerals industry that we have to date, and also concerns about inhalation, right, of fine particles, I think are some of the primary environmental issues that are often talked about. So, not to put any words into Mark's mouth, but he's asking about environmental issues. So I'm interested in seeing your take on those issues, especially in places that don't have often have highly sophisticated regulatory environments.
Yeah,
Some of the countries that you're operating in, what's it look like?
absolutely. So another very, very important question for us, and something which we take very seriously. So in most of the countries where we are operating right now and looking to expand, uh, they're largely global south countries and developing countries. So to that extent, there's a lot of rock crushing happening already
Hmm.
for construction industries, for road making, for railway line making, for concrete. And a lot, I mean, basalt is one of the hardest rocks known to man. So that is a preferred rock for the construction industry to break into finer pebbles. So uh, one of the byproducts of that construction industry process of rock crushing is the waste fines, or the fine powder which gets generated in that process, which we can utilize in our soils. So we are benefiting, almost like a circular economy question here, by a lot of this existing crushing which is already happening, and we can use the waste fines which they produce towards our mission and ensure that the quality and the composition is correct and it's being done in the right manner and legally and with the right permits and all that, and use those existing crushers to uh, to give us the material. However, that doesn't address the question of whether this can actually scale
Right.
and how much how much requirement will be of that. So, uh, a small crushing facility with a quarry alongside it, let's say of 5 to 10 hectares of land, can provide enough rock for covering 1 million farmers. So it's like you don't need a lot of these quarries to really serve the number of farmers we're talking about. And the overall quantity of rocks as well is not going to be anywhere near the kind of rocks which we are already breaking for construction industry. So like less than a percentage of what we are already breaking for construction industry is enough to do the global scale CDR, which I'm talking about here. So we are not doing something or creating a new industry in that sense. The rock crushing industry already exists. The the market already exists. And the beautiful thing about enhanced rock weathering is that largely we are not requiring any land use change. We are using existing farmlands to the carbon removal. Uh, Unlike almost all of other processes where either you have to go grow dedicated biomass or you have to build up large factories of direct air capture plants, which takes a lot of land as well. Here, our factory is the farmland, which already exists. The farmer is already farming. The rock sourcing piece is a very, very negligible portion of the total amount of land which we need. And as I said, one quarry can serve a large amount of area and large amount of farmers. And they're also not large quarries anyway. Now, if we do scale this to a global scale and try to sort of serve the world, then we have to be careful that these dedicated quarries, as they develop, because we will have to build dedicated quarries if we're trying to do a global scale operation.
Right. Right.
Those dedicated quarries which we build are done in a climate and environment conscious way, that the quarrying is done so that the local populations are not seeing any pollution. I mean, as the crushing happens, you essentially have to uh, not allow the dust to escape. So that is, there are technologies for that already existing. It's not like something which is to be invented. It's very, very common to use that.
Mhm.
Similarly, because the land use is not much, the biodiversity impact is pretty limited. Actually, the biodiversity is significantly impacted in a positive manner because of the improved biomes from the land. And the overall foliage trees and all those things are not really impacted much. So really, if we are doing large scale mining, quarrying, and building these, then if the quarry is done, then you have to suitably rehabilitate it, and like you do any coal mine, in fact. But but the fact of the matter still remains that this is not going to be at the same scale as the existing crushing industry already or the coal industry already. It's going to be at a fraction of that scale, and it does not require that kind of land.
Uh, uh, any questions or any data in terms of threat of inhalation of fine particles by farmers?
So you use personal protective equipment when we are applying this. The rock
Hmm.
itself, the rock powder is quite heavy.
Right.
So as you're actually spreading it, it does actually form a dust, but
Hmm.
it really likes to settle down, and it doesn't like to really, if the wind, once it's settled down, it doesn't really like to blow in the wind because it's much heavier than the actual soils. So what we have seen is that you obviously need to be protecting yourself when you're deploying this material. So we provide masks to the deployment community and the farmers as they're seeing the deployment happening. But we do not see, if we are doing it the right way with the health safety norms, which we have created and following those norms, I don't see any risk. But obviously, if somebody is breaking the rules, not wearing the masks and sitting in front of the on the spreader and inhaling a lot of this silicate rock, that is not good for their lungs. I mean, as is any dust. I mean, even even smelling a bunch of just normal soil in your lungs is not good for your lungs. But it is not extraordinarily toxic in any way, which is very different from the just normal dust.
All right. Next question from Charlotte Flodine. It's essentially a life cycle assessment question. What uh, what are the climate impacts of the energy needs in this process, which right, I think is primarily focused on the initial grinding process. Do have you done an LCA on that?
Obviously, yes.
Yeah.
We are selling carbon credits, and
Yeah.
without an LCA, nobody's going to buy anything. I mean, you have to have a very exhaustive, very high quality LCA done, and we maintain that continuously for everything which we do. We monitor every emission which we do. So, um, enhanced rock weathering actually is one of the very unique pathways where the gross emissions as compared to the net removal is significantly in the favor of removals. The emissions required for doing the grinding and the transportation and the spreading are less than 10%. In fact, even in some cases, less than 5% of the gross removal, which will happen from that spreading done. So it is a highly favorable process in that sense. And we've done extensive calculations, but it will depend on how much you're transporting the material, how far you're transporting the material from the source of that material. And today we are still using diesel trucking because electric trucking is not there at scale, and diesel trucking is going to cause emissions. But on an overall balance, the huge amount of co-benefits which is causing and the excessive net removal which is resulted from this allows us to be very comfortable with using diesel trucking to move this material because overall emissions are less than, I mean, mostly 5% for what we're removing.
Okay, thanks for that. Next question from Carl Dantz. The 10,000 pound elephant in the room, which is USAID is among your funders, right? And the question of whether you're highly dependent on US sources of funding and what policy developments across the world would most support your efforts.
Yeah, so yeah, the sad demise of USAID actually has also impacted us in some
Hmm?
ways. But the good thing is that we had not banked the money yet, so we were not depending on it yet. So it was still kind of in the process of coming to us. So we hadn't. We have quickly pivoted and learned to live without it. So it's not a problem for us in terms of our scale up path and our growth direction. But yes, I think the governmental support for making this available to a large number of farmers is something which we will need at global scale. If you're talking about reaching 100 million farmers, the global North governments and the global South governments have to first of all recognize and understand the benefit of this and then support it in various ways, whether it's be subsidies, whether it be carbon credit purchases, whether it be just farmer support. And a lot of these subsidies and farmer support already exist, but for chemical fertilizers and GHG emitting pathways. So all
Right?
we need to actually help these governments realize is that this is actually a better pathway. It is a natural pathway. It helps the farmer and it can reutilize the funding which you're already allocated to favor a higher, better pathway which removes carbon as well at the same time in your
Yeah.
country. So
Have you engaged in that kind of conversation with governments and how's that argument worked with them, right? That seems like an interesting approach, but again, given kind of the conservative nature of governments also in moving to new approaches, right? What's happened so far?
yeah, so I think the first reaction we get from the government is this for real? Are you,
Yeah.
this is this is
Right.
not real. I mean,
Fairy
I've
dust
not heard
again,
anything
right?
about like this before.
Yeah.
In fact, when we go and meet a local administrator, they're like, and what do you want from me?
Right.
You want money from me? You want what support do you want from me? And we're like, we don't want anything from you. Just let us do our job. So they're
Mhm.
like, okay, you're gonna fund this yourself, you're gonna give this away for free. Just doesn't compute in their heads. So
Right.
I think the whole the carbon removal markets and the way we are approaching it in the benefit of smallholder farmer is something which is very new to a lot of governments. And it's also subscale at this point to
Right.
allow for governments to really hop onto it and start taking credit for it. Because at the end of the day, government is all about trying to win elections, right? So they need
Yeah.
to get enough farmer momentum to start feeling that this is a great thing to really get on their manifesto. And that's what we want to happen in each of the countries where we're operating in, that we get enough farmers to benefit from this, that political parties see this as a great opportunity for them to actually benefit from. And then it becomes a movement, and then the governments adopt it, and then the governments give the subsidy. So I think there's, rather than trying to convince them of a pathway theoretically and scientifically, I believe that a better pathway is that let the voters speak, let their constituents benefit from it, and and it'll from that the right bright political leader will automatically catch on to it and try to make it a policy.
All right. Next question. Which carbon standard body are you using to verify your ERW claims?
Yeah, so there are two carbon standard bodies which have a methodology for enhanced rock weathering as it stands today. One is called Isometric, which is a London-based organization, and the other is called Puro Puro Earth, which is a Nasdaq-owned entity, but Finland-based. And both of these bodies are standards organizations which go through the process of diligence and then certifying credits. So we use both of them.
Great. Let's see. Can you say a little bit about your upstream operations? What kinds of air quality impacts might there be from mining and crushing of rocks? I guess we've already covered that, right? And you've done that assessment in each of the countries, obviously, that you've been engaged with, right?
That's right.
Uh, Curious, who do you work with from governments when that initial analysis is done?
So there is the government requirements change from country to country and location to location. So obviously you have to comply with the government regulation anywhere you're operating. And typically there will be a pollution control board or some sort of air norm or environmental norm in that region, which the quarry has to support and be compliant to. So we definitely make sure that is happening. But on top of that, we do our own analysis on top, which is a environmental impact assessment, which is to our standards, which
Hmm.
is beyond the governmental standard, and ensure that the operations from where we are sourcing materials comply with those environmental standards, which we hold ourselves true to.
I guess one final question, and this is kind of a broader sort of market question, right? You've provided some of the projections for people like Boston Consulting Group, right, in terms of how large this market could be, how much it'll grow. Um, the skeptic, which might include me in some ways, says if you look at what consultants tell you, whether it's Boston Consulting Group or McKinsey or somebody else, it often is pie in the sky, right? It's feeding the beast, right? Whoever's commissioning it, they're going to give them a happy conclusion, right? When I look at the market itself, right? Look at CDR FYI's recent reports, right? The reality is that the market is not growing quickly, right? There's very few buyers. It's almost all Microsoft. There's not a lot of new buyers, and one wonders if people like Boston Consulting Group are looking at this with rose-colored or opportunistic glasses, right? What's your sense of whether the market's going to grow enough to be able to scale things like enhanced rock weathering over the course of the next 15 or 20 years?
So I think we have no choice as a
Hmm.
as a species. We
Right.
have to do
But
something about it.
you're right. We do have to do something about it, but we often don't do something about a lot of
I
things,
agree.
which,
I
right?
agree.
Because we didn't do anything about climate change, right? Which is why we're here.
So I agree. I think there's a challenge around getting the governments to move and the public to move. So the the current market environment obviously makes you feel that whether there's a future to this or not. Uh, the good thing which we have observed from our experiences and talking to various customers who are buying from us already and continue to buy from us is that the companies which are committed to a net zero pathway by 2030 or 2035 or 2040 or whatever it is, and are working towards that, have an internal uh, approval, capital allocated, and momentum. And they've committed to their stakeholders, customers, and internal employees that they were going to do what they're supposed to do. So for them to back away now and say that this is not real and we don't care about it anymore and we just want to do normal is not only difficult, also has some morality issues attached to it, and they're actually all of them are going through with it. They're continuing on the pathway. The ones who have not started in the current environment are still sitting on the fence. They're like, okay, maybe we should continue sitting on the fence for a little bit longer before
Right.
we start buying this. Obviously, this doesn't really help the bottom line. That's expensive and all these other things. And the the president of the country is also not really in big favor of it at the moment. It doesn't really seems like so. So maybe we can just leave it on the side.
Mhm.
And that may be the scenario for the next few years. However, the forcing mechanism which I can see is that climate change is happening. It's going to continue to intensify and it's going to start affecting people more and more. And as that happens, the groundswell of people wanting to do something about it will actually increase. We, the good thing about humans is that until it's not our problem, we don't care. But once it becomes our problem, we really care about it. We want it fixed. We want it fixed now. And I think the climate change problem is arriving at our doors very soon. It's going to start feeling different, substantially different very soon. We are in a 1.5-degree increase year already this year. It's not in 4 years, 5 years ahead of. I mean, it's coming. It's actually it was a peak year, and this year 1.5 degrees average increase in the last 12 months has been seen. It might drop down to 1.4, 1.3, but it's happening, and it's going to get to 2 degrees, and we're going to start seeing this severe extremities changes. I mean, I'm sitting in Houston, Texas right now in April, and it's 40 degrees F. And I'm like, this is a beautiful April. I don't know why it's happening. I mean, but this is I'll take it, man. So uh, but it's real and it will also swing the other way. The pendulum is swinging rightly nicely for me right now in April, but it's going to swing the other way in April maybe, and then I'll be complaining. And the complaints will become large enough and loud enough that action will be taken. And that's the action which I'm hoping to count on, and this movement will continue to scale as this action becomes more intensified.
All right, that's a good, inspiring place to end. Shantanu, I want to thank you for your presentation and thank the audience for all of the excellent questions. We will be back next week, focusing on marine liability questions associated with MCDR processes. So I hope you can join us again. And so once again to everyone, thank you and goodbye now.